Hi friends, welcome to my channel. Today I'm going to do a brief session on how to configure SD-WAN in Fortigate Firewall and how to test it. And I'm going to cover all the features that you have in SD-WAN. And by the way, I am having the firmware 640, which is the latest firmware version that we have from Fortigate. So let's get started. This is my main firewall. You can see port 1 is the ISP1, port 2 is the ISP2. These two ports are connected to the ISP1 and ISP2, and my clients are serving the client's traffic is coming to port 3. So this is my LAN port, which is connected to 192.168.1.108, and my ISP IP is 192.168.0.108. So the upstream device is doing the NAT. And in ISP2, we have the interface IP as 14.140.40.108. So we have upstream open source firewall, which is doing the NATing here, which is our pfSense firewall. So, okay, so we have three interfaces on FortiGate firewall, and I'll show you how to configure the SD-WAN. So I guess you will have to enable this, or by default this will be enabled. If not, you will have to enable this and then apply. And I'm looking for some other features as well related to SD-WAN, if there is any. Okay, there's no other SD-WAN feature here, so we are good. Network, and then you will have to click on SD-WAN zone, since I have already created the zone. So if you want to create, you will have to click on create and add the member. So the port that you want to add as a SD-WAN member interface, you will have to do it here by clicking on create new. Or if you want to create a new zone, you will have to click here and then try to put the interfaces in the group. So it is going to create test with two interfaces, ISP1 and ISP2. After that, you can click OK. But then I already have the default virtual WAN link, and in that I have selected ISP1 and ISP2. Let me show you how to do that. So once you create your SD-WAN zone, it will look like this. Then you click OK. Then you have to choose the interface. Okay, so once you do that, it is going to remove the configuration from the existing virtual WAN link. This is the default, I guess. So we have created SD-WAN test, and in that we have ISP2, ISP1 defined. Okay, and whenever you do that, you will have to define the gateway. 192.168.0.1 is the ISP1 gateway, and for ISP2, you will have to put the gateway. So you might not see this configuration if you are doing it for the first time, since I have already added this. So that is the reason why you are able to see that. Let me try to delete everything. I will stop the video for some time so that I can remove all the configuration and I can show you from scratch. All right, friends, so I have removed all the configuration. So now if you go to SD-WAN zone, you will just see the one. Okay, I have removed that as well, so no problem. You can see there's nothing here. absolutely nothing here, so I'm going to do it from scratch. So let's go to SD-WAN zone, create the SD-WAN zone first. And then once you create on member, it is going to show like this. It is not going to show you the interfaces. Well, you will have to create the interfaces. Click on ISP1 and then put the gateway 192.168.0.1. Keep the cost as 2 because I want to put the traffic on ISP2. Okay, click here and then create one more. Put the gateway as put the cost as 1. So you have two interfaces in SD-WAN zone. Okay, I guess I added it to the wrong zone. I'm going to give it as 2. I'm going to give it as 1. So we have two. Okay, so we have two interfaces here. Okay, so I believe it is going to be inside this, and then you can assign zones for the SD-WAN interfaces. Well, that is what I believe. So we will see it later. Let's see if we can add another interface just for testing. Okay, so whatever interface you have, it goes inside the virtual WAN link, and then that goes inside the SD-WAN zone. So we will check that after some time. Okay, so now we have our virtual WAN link, which is having ISP1, ISP2, and we are going to create the IP SLA to, regulate the traffic flow from ISP1 and ISP2. So one is going to be ping, and I'm going to ping the server. Okay, and my all the interfaces that are there in the SD-WAN virtual link is going to, all of them are going to ping the IP address 8.8.8.8. So click here. I don't want latency threshold. I don't want jitter threshold. I want the packet loss threshold. Let's keep it as 10, or let's keep it as 5. Or keep it as 1. Yep. And the link status, I want the interval to be 500 milliseconds, and this is the number of retries and the interval between the retries. So update static route, well, by default it is enabled, so we'll keep it at. We'll keep it as it is. Okay, so now you can see here. So it will start pinging the IP address, and it is going to update the status. Well, right now you see ISP2 having the loss. Let's wait for some time. We're going to create a default route pointing to SD-WAN. So these are the probes sent from port 1. Let's see what we have from port 2. Okay. Okay, so the gateway is incorrect here. It is going to be 109, so that was the issue. Okay, once I do that, let's see the status now. Okay, that's cool. Okay, so both the ISP1, ISP2, both are up with almost similar latency. There's no loss on the link, by the way. And my SLA is okay. So whoever meets this criteria will be chosen. Okay, so now we are done with the virtual link and the member definition here, ISP1, ISP2 under virtual WAN link. And then we are done with the SLA creation. Okay, let's try to, okay, SLA is done. Now we will go to SD-WAN rule. We will create a SD-WAN rule. Source, I'm going to keep it as all. Destination, keep it blank. Address all, any. And then here is the options. So first of all, I will go with best quality. Okay, so I'm going to put the interface preference as ISP2, ISP1. So by default, it is going to use ISP2 if the ISP2 is not meeting the SLA, which I have defined in SLA, then it is going to fail over to ISP1 automatically. So let's try with best quality interface with the best measure performance is selected. So let's try this. Measured SLA, I'm going to select the one that I've created, and the quality criteria, I'm going to put it as packet loss, since the latency is almost similar for both the ISP1 and ISP2. So let's click OK. So now our SD-WAN rule is configured. Hit count is 0. So since we don't have any traffic, SD-WAN interface and zones both are configured. You have performance SLAs also defined. So you can see here the performance SLA and the loss. And we have a static route, default route pointing to SD-WAN interface, and SD-WAN we have already defined the gateway under this. And once you are done with these three configuration, then you can create a normal firewall policy to allow the traffic. You can see here. So now we are done. Now we will try to initiate some traffic. So this is the client that is going to initiate the traffic, and the client is connected to the port. Like I said earlier, it is going to connect to port 3. So port 3 is having the IP address 192.168.1.108, and the client is having the IP address 192.168.1.107. So let's check if we have the connectivity to our port 3 of the firewall. Okay, so we have the 108 access. We can see here all the traffic is supposed to go or exit out via port 3, and it comes to this firewall, and then the SD-WAN magic happens. Okay, so what we can do here is that we are going to ping the open DNS IP, and let me show you the SLA info. So right now the SLA is ISP1 0% loss, ISP2 0% loss. Latency is almost the same. And then if you click on SD-WAN rule, it is going to show you that ISP2 is preferred, since the ISP2 cost is 1. In the configuration here, you can see that the cost is 1 for ISP2 because I want to put the traffic on ISP2, and the cost of ISP1 is 1, or sorry, 2. Since I don't want to put the traffic on ISP1, only if ISP2 fails, I want to put the traffic on ISP1. So you can see the stats here. Okay, so our rule says ISP2 is the one which is actively processing the traffic. So let's test that. I'm going to ping the open DNS IP. So you can see here, I'm able to ping that. And matter of fact, I can show you that it is not exiting out via port 1. Rather, it is going out via port 2. So you can see here, the request initiated from the client is exiting out via port 2. So now let's say that the ISP2 is going to get faulty, just to demonstrate how seamless the traffic flow or the failover is. So now as you can see here on SD-WAN tab, that ISP2 is active. So what I'm going to do here is I'm going to go and I'm going to black hole the traffic. I'm going to black hole this traffic, and I'm going to show you the effect as well. So you can see here, immediately it took over to ISP1. And in the zone IP SLA, if you go see, you can see here ISP2 is down. So ISP1 is processing the traffic. You can check the status here in SD-WAN-Rule, which says ISP1 is active, which is automated behavior shown by the Fortigate Firewall. You can see here it is still pinging. So it might take some time to, clear the session. You can see here the session is resumed on port 1. Earlier it was from port 2. You can see here. So now again I'm going to do a failover. This time I'm going to bring up the ISP2 SLA IP so that the traffic fails over back to port 2. So what I'm going to do here is I'm going to go to pfSense. I'm going to disable this route, and then I'm going to apply this. Let's check the status here. So you can see the ISP1 is still active. The performance SLA is 80%. That's the reason why it's not failing over back to ISP2. Let's wait for some time. It might subside in some time. Okay, it is going down. You can see here it is still preferring ISP1, and my ping is still going on. There's no ping on IS port 2. So now both are okay. It brought down to 11%, just 1%. Okay, so now there is no loss on ISP2. So if you go to WAN rule, it says ISP2. So now you will not see the traffic because of the existing session, and since the ISP1 is already active. So what I'm going to do is I'm going to stop the traffic. I'm going to reinitiate the traffic, and then I should be seeing the traffic here. As you can see here, the traffic resumed over to port 2. The traffic is going out via port 2. So this was about the redundancy with ISP1 and ISP2 using the SD-WAN feature with the ping SLA. Well, you can create multiple types and kinds of SLA here. This was the ping-based SLA. You can have HTTP, TNS, whatever you want, and you can have multiple members as well. So one is enough for me. So now I'm done with this. I'm going to create a new SLA for load balancing. Oh, so that we can test the feature of load balance. I'm going to put the IPS, okay, and I'm going to put all SD-WAN member because I want both the interface to ping 1.1.1.1 so that I can, measure the criteria. So I don't want this. I don't want this. Let's say 10%. And if both the interface meets this criteria, we are going to use both the interface for load balancing. Okay, you can increase this and you can decrease this. I mean, you can adjust the configuration here. Click OK and then check the status. It says up, 0% loss. So you can use ISP1 and ISP2 as well. Since if by any means if by any chance this is not reachable, then it will remove the interface from the load balancing criteria. So you can see here it has removed the interface from the load balancing criteria. I mean, this is just a SLA. If you use this SLA in the SD-WAN rule, it is not going to consider the ISP2. So since I'm going to use it, what I'm going to do here is I'm going to disable this, save, yes, apply the change. Okay, so now you can see both the ports are active, but since the criteria is 10%, it has to come below 10% so that the SD-WAN rule can, use both. Okay, I'm going to put the option of maximum bandwidth SLA. I'm going to select the SLA that I created. So you can see here maximum bandwidth total, the traffic is load balanced among interfaces that meets the SLA target. So right now I have two interfaces, ISP1 and ISP2, and I believe ISP2 is facing the loss and it might subside in some time. So it is 10% right now. So let's try to do this. And by the way, if you want to, have further granularity in the SD-WAN rule, then you can do that via CLI. So you can see here, it is choosing both the interface 1 and interface 2. When you have the SD-WAN feature, the SLA is here. Both the interfaces are way below the 10% loss threshold. And then the traffic will, I think it is based on the session. So if you initiate the traffic, it should go out via port 1. And then if you have multiple users or multiple sessions, it might load balance the session among the interfaces that met the SLA under the load balancing criteria. Since I'm initiating the traffic from a single client, so you will not be able to see that on port 2 because it is having the existing session on ISP1 link. So yeah. So you don't have any traffic on port 2. Let's try to do something. So you can see here ISP1, ISP2 rule says prefer ISP2 over ISP1. Okay, this is the maximum bandwidth SLA, which says load balance the traffic, and these two interfaces will be used if it falls under the SLA that we have created, the load balancing SLA. So let's try to block the IP 1.1.1.1 so that we can bring down the ISP1. Since the traffic was going out via ISP1, so I'll try to bring down the ISP1 by bringing down the SLA. So you can see here, now I have brought down, okay, I have brought down the ISP2. So, okay, that's not an issue. So let's try to see. Since I don't have any control over ISP1, so I cannot do things with ISP1. So I can only test it with ISP2. So ISP2 is down. And then in the WAN rule, you can see here, it is choosing ISP1. It is not choosing ISP2 for any kind of traffic. Once that is up, it is going to bring up the SLA. And even then, okay, ISP2 is up, ISP1 is up. Once it is under SLA, it is going to consider both the interface for load balancing. Since in load balancing criteria, we have given the packet threshold as 10, loss threshold as 10. So once this comes under 10% threshold, it is going to consider ISP1 as well as ISP2 for the processing of traffic. So you can see here, it is putting the traffic on port 2. And I believe you should not see the traffic on port 1 since it is doing load balancing based on the session and the client. So the session load balancing is happening on port 1 and port 2. Earlier you were able to see that on port 1, now it is on port 2. Since I guess it is session based load balancing or maybe the client based load balancing, I'm not sure. So this was about the load balancing feature where both the links will be used, and you will have to define that under SD-WAN feature here. And one more thing that I was trying to tell you is the granularity that you can bring into the SD-WAN rule. Here, if you see that by default, you don't see that information like, the in interface selection or the negate option, but you can do that via CLI. If you go to config system, SD-WAN, config service. So if you set the input device, you can select the input interface here. So my input interface is going to be port 3, which will receive the traffic from the clients. And then I can do multiple things with CLI, like I can negate the source. You can see here destination negate, source negate. So there are multiple options here available that you don't see it in GUI. So the GUI is not showing up all those granularity, but then you can do it from this CLI like I showed you. Here there was no option of incoming interface selection in GUI, but then in CLI, well, you can do that. And I've done that. Let me show you one more time. So you can see here in service option, you have the input device as port 3. So you have one more level of granularity in terms of the SD-WAN rule, which decides what to do. So you can see here, this is the criteria. You can have multiple interfaces in this particular interface selection tab. And if the interface meets the SLA, it is going to do the load balancing among all the interfaces that met the SLA. And I don't know whether there is any flexibility of choosing how you want to do the load balancing, but then yes, this is what you get out of box. And let's try the manual one. So the manual one says manually assign outgoing interfaces. Okay. So since I have selected ISP2, okay, let's try to do it as ISP1 and then ISP2. Okay, so I'm going to prefer ISP1 over ISP2. So this is the manual settings that you can do. You can see here ISP1 is preferred. Let's try to initiate some traffic. You can see here it is going out via port 1, which is our manual selection. Here you can see this is the SLA. It is still having the load balance SLA. If you want, you can change it. So the SLA says 10% packet loss. Okay. In this particular criteria, which is having a manual failover, you don't have any SLA, so you don't have to worry about that. So the only criteria is that the preference. Port 1 is preferred, and then if not port 1, then port 2 is preferred. So let's try to reverse the. Okay, that's better. So now you can see here ISP2 is preferred over ISP1. Well, this is a manual what do you call settings. And let's try to do something. Let's try to disable the interface. Okay, it's going to bring down that. Not a good idea. So I'm going to bring down the interface just to see if it fails over to ISP1 or not. So you can see here, but then since it is a manual setting, so you don't have to worry about the SLA because you don't have to define SLA while doing a manual thing. So you can see here it automatically adjusted the correct ISP. Port 2 was down, so it automatically adjusted to port 1. So let's bring up the port 1 to see whether it fails over to port 1 or not, port 2 or not. Okay, so let's go back to WAN rule. Okay, so now it fails over back to ISP2. Let's try to test it with the help of traffic. Disable this. Now we will. Okay, so now we are initiating the traffic. Let's see, where are we receiving it? So we are receiving it on port 1. Port 2 is down, so you shall not basically see the traffic on port 2, but then let us do some changes here. Let us break up the port 2. So you can see here it failed over to ISP2. Let's try to check that. Maybe because of the existing session. Well, we'll try it one more time. Okay, so now we are able to see the traffic on port 2 automated. Well, that is also working. So the other option that we have here is best quality. Well, under best quality, if the interface with best measured performance is selected, so you will have to basically define the SLA. I'm going to go back to the ping SLA, and I'm going to use the same preference, ISP2 first, ISP1 second. So the criteria here is the ping SLA packet threshold 1%. So if the criteria is met, then it is going to select that interface. And by default, my preference is port 2. So as long as port 2 is having the packet loss less than 1% or 1%, it is going to select port 2. If ISP2 is having loss more than 1%, like how I have defined here in SLA, it is going to fail over to the port 1, which is ISP1. So let's test that by blocking 8.8.8.8 here. So let's try to see ping SLA. You can see here WAN rule. Okay, so it is now selecting ISP1. So we don't have to test that. If you want, you can test. Let's try to do testing. Since the session is active, you can see here the traffic resumed on port 1. So that is also working. And before that, I would show you that the traffic is not there on port 2. Okay, so as soon as I do this disable, okay, so now our preferred path is ISP2. The best of, okay, I guess I selected the wrong option here. You can see here best effort. Okay, so now let's see. So ISP2 is not preferred, maybe because of the loss. Yeah, once the loss subsides, it is going to prefer ISP2, like I said. So this is the third options that you have under performance under the policy. And the other one is the low cost interface that meets the SLA target is selected. Okay, so basically the same, the interface with the lowest assigned cost is selected. In our case, it is going to select 2. Since ISP2 is having the cost of 1, that's why you see ISP2 being preferred. That completes our options that we have in rules, basically. So this was the one that I was talking about. So you can select the zone as well. Instead of outgoing interface, you can select the outgoing zone. Anyways, I think we are done with all the attributes, all the options available with us on FortiGate Firewall for the SD-WAN feature on 640. And we have tested the failover scenarios as well. We have created a lot of SLAs as well. So that brings us to the end of this video. I hope you enjoyed it. And please do subscribe to my channel, hit the like button, and stay safe. Stay tuned. Have a good day. Bye bye.